So today we are going to continue from where we stopped, and today we are going to be writing a function to implement search in a binary search tree. So basically, this function is going to take a value and then it's going to take some value, a key, and it's going to go through this binary search tree. And if this value is found in this binary search tree, it's going to return true. And if not, it's going to return false. So let's quickly write it. And this function is going to be a Boolean function. So let's say public Boolean. Let's call it contains. Okay, in value or in key. Let's use it a key. Right. So the first thing we want to check is if this key is equal to the root. If the key has been found, so we are going to first check the root of the tree. So we are going to say if value is equal to data. So this is more like the current node we are checking. If the node, if then return true. All right. So we are talking about key. Okay. So asking of return statement. Let me push down so that we have some room. Okay, good. So basically, it's the same process that it takes to insert, and that is the same way it's going to search. So else, so in this case, else, it means that the root is not in this tree. So we are going to now check if this value is less than the data, if this key is less than data, and if it's less than data, we are going to check if we are going to move to the left subtree. So if left if left equal to null, then return false. Okay. So else is not null. So we are going to say else the left subtree contains some things. So let's recursively call this contains method in the left subtree. So we are going to say else return contains left return left dot contains key, right? Perfect. All right. So at this point, we will now check. We are now going to. So we have else if. Okay. So I think I've added some redundant. So I'm going to actually take all this, and I'm going to put this here. All right. So at this point, so here perfectly is fine, but I'm trying to just make sure everything is fine. So I'm going to push back this, I'm going to push back this, I'm going to push back this as well. I'm going to push this back, I'm going to push this back, I'm going to push this back. Okay, so so else if key is less than this. So in this case, let's check where this guy stops. So fine. So I'm going to just say else. So at this point, I'm now going to look on the right subtree. So in this case, I'm going to say if right is equal to null. I'm simply going to return false. Then else I'm going to return right dot contains key. Okay, so what I'm going to do now, everything is fine. So what I'm going to do, I'm going to clean up this code because it tends not to be very, very okay. So we have this is fine. So we have else, we have this. So basically, this is going to, this is fine as well. So how else? So how else? Return this. So this actually should be outwards because this follows from this. Perfect. Else, else, fine. So this is the last else statement. So I think we are good to go. So everything is fine. So let's just see exactly what is happening in this place. So what we are saying is that, let me pick up my pen. Okay. So what we are saying is that the first thing it does is going to check whether the key, so this is our key, is going to compare the key to check if key is equal to data, and if the key is equal to data, return true. If not, it's going to check if key is less than 3, and if it's not less than 3, the next thing is going to check if there is a left subtree. If there is no left subtree, it simply returns false. But if there is a left subtree, it's going to just go to the left subtree and recursively call the contains method. And it does the same thing in the right subtree as well. So this is how to search for an item in a binary search tree. In the next lesson, we are now going to see how to delete an item and also how to print items in a binary search tree in a sorted order. I'd like to thank you for viewing and also like to remind you to subscribe to my channel, like this video, and leave me a comment if there is something informative for you found.